The mean of a binomial distribution, you use this little Greek letter mu. It looks like a backwards U, right? A U usually is this way. A mu. It's almost they draw it like a more like a U there. Um, I always thought of it as a mu. It's kind of like a, a cursive M almost. Um, but that's the symbol there. Um, of a the mean of a binomial distribution is given by n, the number of trials, times the probability of success. Um, so when we're looking at the full probability distribution, you got to look at all the different parts. So we're not going to do this for a 20 question quiz. We're going to do this for a 5 question quiz. Um, but the whole idea is it's basically the same as a binomial distribution. So of course you can choose notation in all of this. But if it's a small enough piece, you can actually even use Pascal's triangle, which we know uh, also gives us the same values of all the choose notation. And I know on this problem here, we're going to be talking about a 5 question quiz, so I'm going to just give you Pascal's triangle row here for fives. It's 1, 5, 10, 10, 5, and 1. 1, 2, 3, 4, 5, 6. Yeah. 1, 5, 10, 10, 5. Yeah, that's right. Okay. So that's just going to save us a little bit of time there instead of having to type in all these choose notations. So Pascal's triangles are kind of handy. It's kind of interesting. We started with them, then we learned combinations with the binomial theorem to kind of move away from it. But sometimes now we know that both of them we can choose what might be the easier option, and in this case, that's Pascal's triangle. Um, so imagine a 5 question quiz with 4 part multiple choice for each question, right? So each question has got 4 choices, A, B, C, or D, and only one of them is correct. All right. So we're going to determine the probabilities associated with the number of questions answered correct by calculating the probability distribution. So we need to expand out the probability of 25% correct and 0.75 incorrect for the fifth power. Now, this is kind of misleading here. This really should be p plus q to the fifth. Then you expand it all out, right? But that's the idea here. So first term, it's got a coefficient of 1, getting 5 correct, and uh, none incorrect. Or sorry, and 0 incorrect. Yeah. And then we got our next coefficient, which is 5. Our probability of success is going to go, the number of times that happens is down 1, which means I have to miss one of the questions, plus 10 times the probability going down to 3. But here I have to miss another one of the questions. Probability go down again. So this time I'm only getting 2 of them correct, which means I have to get 3 of them incorrect. 1 correct and 4 incorrect. And finally, the probability of getting 0 correct and missing all 5 of them. Okay. And basically, what each one of these coefficients is kind of representing is the number of different possible tests that can happen that way, right? So we take a look here. 1 plus 5 plus 10 is 16. So there's 32 possible tests. And um, so that's kind of the idea there, right? And if you think about it, there's 2 events, correct or incorrect, and to the fifth power, that's 32. That's pretty cool, right? Anyways, now what we need to do is we need to plug in these probabilities of success and failures into the corresponding thing. So I have 1 times success happening 5 times and failure happening 0 times. 5 times 0.25 to the 4 and 0.75 to the 1. And you're just kind of filling this out now. I mean, it's one of those things, after you see this video, you might say, oh, I could just do that in one step, and that's perfectly fine. Some people like to see it in multiple steps broken out. It really kind of helps you figure out what's actually happening in each one of these scenarios when you're just talking about success and failure instead of looking at their probabilities. Um, Kind of helps build understanding of the problem as you're going along. But really, when it comes down to it, right, it's all about the calculation, and that's really going to have the most understanding here. Wait a second here. 5, 4, 3, 2, 1, 0. 5, 4, 3, 2. Oh, okay, that's my problem. I messed up my coefficients. And then another 5, 0.25 to the 1, 0.75 to the 4, plus, I'm not going to multiply by 1, 0.25 to the 0. Ah, crap. I ran out of space. Plus 1 times 0.25 to the 0, 0.75 to the 5. And it's not a bad idea to think about it here. 0 correct, 1 correct, 3 correct, 5 correct. Just filling out some of them. That way you know what each one of those terms mean when you actually calculate them out. So I'm going to do that now. And I'm going to do them one at a time. So 1 parentheses 0.25 to the 5, close parentheses, open new parentheses 0.75 to the 0, and put that all in, we get a 0.00098. Ooh, pretty low percentage of that happening, right? Now, one of the handy bits of actually doing this um, crap. The way I did is now I can just retype it and change the coefficients and the exponents. So this is 0.015, okay, and make that a 10, drop that down to a 3, up to a 2. This is one of those things where I imagine if you're watching at home, you're probably like fast forwarding the video at this point, which I completely understand. I'm just freaking typing stuff in. It's not too exciting. It is good to take a look at it and think about um, uh, why these are all happening this way. You know, when you're typing them in yourself, it's a little bit easier to spot what's happening or noticing when something weird is happening. Why am I rounding it the way I am? 396. I really should just round all these to the nearest 10,000th. That's what I've been doing for those. So down here, let's call this 0.001. 1, 0, and 5 other changes, and I get plus 0.237. Okay, so there's all my probabilities to the nearest 10,000th, or to the nearest tenth of a percent. Right. Okay. And if we add all of those together, we should get, so 0.001 plus 0.015, 0.88 plus 0.264 plus 0.396 plus 0.237. We add that all up. I add it all up, I get 1.001. So pretty close to a 1, which would be 100%. It's a little bit off, but that's just because of rounding errors. Hey, look at that. It was this guy right up here was the problem. It's basically so unlikely that you'll guess and get all 5 correct that it's not even like it actually is the error inside of the problem. Interesting stuff. Okay. So that is part A. One thing, maybe we'll go back to adding this here. 5 correct, 4 correct, 3 correct, 2, 1, 0 correct. Just to kind of refer to that later. Um, well, let's go. Yeah, we're going to come back to this in a video here in a second because this video is getting long. All right.